live from Chemistry 101, giving you all the freshest information on society's latest issue today. Does an ideal gas exist? The ideal gas law is a simple model that allows us to predict the behavior of gases in the world. Physical laws as well as the gas laws describing the behavior of a gas under various conditions of pressure, volume, and temperature.
One of the three fundamental states of matter is gas, with distinctly different properties from the liquid and solid states. The result of all these studies was a set of fundamental mathematical equations known as the gas laws that applied equally well to any gas.
The remarkable feature of gases is that they appear to have no structure at all.
Also, we will be talking about the relationship between volume and the pressure, as well as the comparison between volume and temperature. Through this describes the behavior of an ideal gas. It closely approximates the behavior of real gases.
So what happens to the volume of a gas as the pressure on it changes? Giving you the life experimentation with the real-life application of a said gas laws, the Charle's law and the Boyle's law. I am your daily experimenter, Adrian Luis Basalio.
This is Sheena A. Alejandro.
I am Grazel Azores.
This is Ina Grace A. Caudilia.
My name is Christian Caparas.
Live from Chemistry 101.
So for tonight, we are about to discuss The Gaseous State of Matter by Robert Boyle and Jacques Charles. Gas is a state of matter that has no fixed shape and no fixed volume. Gases have lower density than the other state of matter, such as solids and liquids. In addition to that, there is a great deal of empty space between particles which have a lot of kinetic energy. The particles move very fast and collide into one another, causing them to diffuse or spread out until they are evenly distributed throughout the volume of the container. Now let us discover the two chemists that are very well known about this topic. Charles, born on November 12, 1746 in France, and died on April 7, 1823, at the age of 76 in Paris, France. Subjects of study is Charles' law. His inventions was balloon. Charles was born on November 12, 1746 in Beaugency, France, and died on April 7, 1823 at Paris, France. Charles is a mathematician, physicist, and an inventor who with Nicholas Robert was the first to ascend in a hydrogen balloon, year 1783. About 1787, he developed Charles' law concerning the thermal expansion of gases. Let us now move on to Robert Boyle. Boyle was born on January 25, 1627 at Lismore, Ireland. He died on the 31st of December, 1691, at London, United Kingdom. He was known for Boyle's law and corpuscularianism and at the field of physics and chemistry. He was an Anglo-Irish natural philosopher and theological writer, a preeminent figure of 17th century intellectual culture. He was best known as a natural philosopher, particularly in the field of chemistry, but his scientific work covered many areas, including hydrostatistics, physics, medicine, earth sciences, and natural history. And to know more about this topic, let us now move on to the next reporter.
Hello guys, so today we're gonna focus on the gas laws, particularly Boyle's law and Charles' law. Now let's talk about Boyle's law. Boyle's law tells us that the volume of gas increases as the pressure decreases. It is basically referring to the pressure and the volume, while in Charles' law tells us that the volume of gas increases as the temperature increases. We are now comparing the volume and the temperature. Now, in Boyle's law, assume that we have a gas and it experiences some sort of a change. Maybe we increase or decrease the pressure and change the volume in some sort of a way. Now, we have the P1, V1 is equals to P2, V2, wherein it is the pressure and volume multiplied together before the change is equal to the pressure and volume after the change. In Charles' law, relating to the volume and temperature, we have this formula. V1 over the temperature, the volume over the temperature before the change is equals to V2 over the temperature after the change. Now, whenever we are using temperature with gases, we always have to remember to use it in Kelvin temperature. Kelvin temperature is found by taking degrees Celsius and adding 273 to it, and then we get a temperature in Kelvin. Now, keeping that all in mind, let us go ahead and hear some other example relating to these two gas laws. Let's go! Trivia time! On August 27, 1783, Jacques Charles launched the first hydrogen-filled balloon using the gas produced by the reaction of sulfuric acid on iron filings. Among the 50,000 witnesses of this event was Benjamin Franklin. The balloon flew northwards for 45 minutes and landed 21 kilometers away in the village of Gonesse, Paris, France, where the reportedly local villagers destroyed it with pitchforks and knives. The frightened villagers thought it was a kind of a monster from the sky.
Hi, I'm Sheena A. Alejandro and I'm here to give you some example of Boyle's gas law. Very often, Boyle's law used to compare two situations, a before and an after. You can say P1 V1 is equal K and P2 V2 is equal K. So you can write Boyle's law as P1 V1 equals P2 V2. Let's see an example. A tire with a volume of 11.41 liters reads 44 psi on the tire gauge. What is the new tire pressure if we compress the tire and its new volume is 10.6 liters? First thing we need to do is to write out Boyle's law and substitute in what we know. This is one of those before and after situation. So let's write P1 V1 is equal to P2 V2. So let's substitute it. 44 psi times 11.41 liters is equal to P2 times 10.6 liters. Then solve for P2. Divide both sides by 10.6 liters. And 44 psi times 11.41 liters divided by 10.6 liters. Therefore, P2 is equal to 47.36. Then we round it off with two figures. Then the result is 47 psi. So let's see another example. A syringe has a volume of 10.0 cc's or 10 cubic centimeters. The pressure is 1.0 atmosphere. If you plug the end so gas can escape and push the plunger down, what must the final volume be to change the pressure to 3.5 atmosphere? So again, let's distribute the given into the given formula. P1 V1 is equal to P2 V2. It's 1.0 atmosphere times 10.0 centimeter cube equals 3.5 atmosphere times V2. Let's solve the V2. Divide both sides by 3.5 atmospheres. Then it becomes 1.0 atmosphere times 10.0 centimeter cube divided by 3.5 atmosphere. It is equals to V2. Then solve it. The result is V2 is equal to 2.9 centimeter cube or 2.9 cc's or 2.9 cube centimeters.
So, ang topic ko today is problem solving gamit ang Charles Law. So, sa Charles Law, sinasabi ay volume and temperature are directly proportional to each other. So, V is proportional to temperature. Pwede natin siya isulat mathematically ng V is equal to KT, na kung saan ang V ay ang volume, T for temperature in Kelvin, and K for proportionality constant. Para makuha natin yung K, which is proportionality constant, pwede natin i-arrange yung formula. Magiging V over T is equal to K. Madalas kasi ang Charles Law, ginagamit siya para magkumpara ng dalawang sitwasyon. Halimbawa, the before and after, na kung saan pwede mo sabihin na ang before ay V1 over T1 is equal to K, at yung after naman is V2 over T2 is equal to K. Kapag pinagsama natin, gagamitin natin siya sa formula, pwede siya maging V1 over T1 is equal to V2 over T2. So let's set an example. A hot air balloon has a volume of 2,800 meter cube at 99 degrees Celsius. What is the volume if the air cools to 80 degrees Celsius? So, gagamitin natin yung Charles Law, which is yung V1 over T1 is equal to V2 over T2. Lagi rin nating tatandaan na i-convert natin yung temperature to Kelvin. Na ang formula ay Kelvin is equal to degrees Celsius plus 273.15. Yung 273.15 ay constant. Kaya ngayon, gagamitin natin siya, i-convert natin siya. So, meron tayo dito na 99 degrees Celsius plus 273.15. Ang kalalabasan nun ay T1 is equal to 372.15 Kelvin. Yung T2 naman natin, yung second, is 80 degrees Celsius. So, 80 degrees Celsius plus 273.15 is equal to 353.15 Kelvin. So, now, let's solve for V2. First, yung 2,800 meter cube is yung V1 natin over 372.15K na Kelvin natin, yung temperature natin, is equal to V2 over 353.15K. Tapos, i-multiply natin siya both sides. So, magiging 2,800 meter cube times 353.15 Kelvin divide by 372.15 Kelvin is equal to V2 multiplied by 353.15 Kelvin over 353.15 Kelvin. Na-cancel out na natin yung 353.15K sa side na to. Kaya ang magiging sagot natin is V2 is equal to 2,657 meter cube.
So what is up mga kasayko? We'll do an experiment about Charles' Law and Boyle's Law. Okay? Let's go! But first, we need a proper attire when doing an experiment. Okay? So, unahin mo natin suotin ang lab gown para cute. So next is yung face mask para iwas COVID. So next is yung surgical gloves. It protects our hands from unwanted chemicals. Diba? Napakadelikado na experiment natin kaya kailangan natin ng gloves. Bilisan mo girl, tagal mo naman isuot niyan. Sige, kaya mo yan. Go lang. So okay na. Next is yung medical hairnet or yung surgical hairnet, kung ano man tawag nyo dyan. And last but not the least is yung goggles or yung medical goggles. Langoy na ako pero hindi siya pang langoy, okay? So now we are all get up and ready. Let's do first the Boyle's Law experiment. So the materials we needed are straw, balloon, oh my god! Wow! huwag na nating isama yung balloon na yan. So next natin is yung plastic bottles. Include nyo na rin dyan yung tubig. So now, we are ready to do our experiment. Okay? Make sure na nabutasan nyo na yung dalawang bote sa magkabilang gilid para mapasok nyo yung straw sa gitna nito. Parang ganito. Ayan. O, sige, lapit kayo. Tignan nyo kung gaano kataas yung tubig nung sa isa. Compare dun sa kabila. Okay? So, tanggalin na natin tong bottle cap dahil dyan natin ilalagay itong balloon. First, bombahan muna natin. Shing! Ayan, okay na. So, make sure na tight yung hawak nyo para hindi lumipad yung balloon. So, okay. Ayan, ilalagay na natin siya sa taas ng bottle. Ayan, so medyo mahirap pala siyang gawin ng naka-gloves. Pasikat kasi ako eh. Yan, hirapan ka tuloy girl. So, ayan na. So, i-release lang natin yung pagkakahawak natin sa balloon para ma-release yung air, which represents the pressure while the water represents the volume. So, while the pressure is increases, the volume decreases, and vice versa. So, tapos na tayo sa Boyle's Law experiment. So, let's go naman sa Charles Law experiment. So, what are the materials needed? First is yung plastic bottle. Second is yung fire. Next is yung boiling water. Kayo na bahala sa kaldero. Buhaya. Shut up naman. Lastly is yung tongs. Okay, so let's start by opening the cup and crushing the bottle o yung pipipiin yung bote.
No! God, please, no! No!
So now that the bottle is crushed, we need to seal it using the bottle cap so that the volume will not come out of the bottle. So ngayon, handa na tayo magluto ng bote. Gumawa ng experiment. In Charles' law, as the pressure increases, the volume also increases. So kung makikita nyo, unti-unting bumabalik sa original shape yung bote, no? So medyo malapit na siyang maluto, no? Bumalik sa kanyang original shape. So ayan na nga. Bumalik na yung bote sa kanyang original shape. Sana all bumabalik. So that explains the Charles law. Ouch, mainit. So ayan, nakikita nyo, no? Galing, no? Galing, galing, galing. So now, we are done for the day. So pack up na. Okay? Init eh. Okay na? Ha? Uy! May pakita!